We are going to continue our centers of triangles. We're going to look at the centroid and the orthocenter today. So again, I'm going to highlight my centroid. It's still point M in orange. And it is created by medians. Median, as you know, means the middle in statistics. It's also a median on a street is usually a space in the middle. So the median, I'm going to highlight the medians here. I have a median that goes from the vertex to the midpoint of the other side. So Y would be the midpoint. That is why we have double marks here. Then we have angle B's median. And it splits side AC equally because that means Z is the midpoint. And then we have angle C. The median goes to X. Try that again. And it splits side AB into two congruent pieces because X is the midpoint. So median connects the vertex of the triangle to the midpoint of the opposite side. And that's what's going on with our important facts. Our important fact is a median, a centroid. No, actually it is a median. Is created by a vertex connected to the midpoint of the opposite side. Now, another property that we have with this is that the centroid is 2/3 the distance from the vertex of the midpoint. 2/3 the distance from the vertex to the midpoint. Now, pause it here. If you need to get the color coding down, I need to erase it to show you another property. Okay, so one of the things that I've learned about centroids is this part from C to M is 2/3 of the length. So we're exploring that property a little bit more. And the property from the rest of it is 1/3 of the length. Another interesting property of it is that if this piece is A, that's the 1/3 part, then this piece is twice that amount. Let me repeat that again. If this piece is a certain length, that's the 1/3 part that corresponds to the yellow part, then the orange part, the 2A part, would be twice that. That's going to become important. We're going to move on to some examples. Okay, so here's our example for centroids. I have a centroid here. Tells me G is that centroid, so that is where all of these medians intersect at. And again, a median goes from the vertex to the midpoint of the opposite side. It tells me that GD is 27, and I want to know what's GB. Okay, well GB is part of median BD, so that tells me that my 27 is 1/3 of the length, and that means that GB is 2/3 of the length. I also know that if 1/3 of the length is represented by a variable A, then the 2/3 is twice that amount. So that means that if GB is going to be twice the 27, and twice of 27 is 54. Now another way that I can solve it is I can set it up as an equation that I know 27 is equal to 1/3 of the entire length, which is BD. So to solve for BD, I would have to multiply everybody by 3. The opposite of dividing by 3 is to multiply by 3, and I get 81. 81 is equal to BD. Well, I know GB is 2/3 of BD. Well, now I know what BD is. BD is 81. So I could take 2/3 of 81. Well, 3 goes into 81 27 times, and that 3 would cancel. And here I've got 2 times 27 again. So 2 times 27, once I simplify 81 and 3, gives me 54. And again, this is 2 different options. Okay, example 2. Again, we have G as the centroid, and that we're given GA is 48. And I want to know what the whole length of the median is. What's AF? Okay, well again, I know that GF is supposed to be 1/3 of the length, and 48 is 2/3 of the length. And I also know that if 48 represents 2 times the amount, then my GF should be half that amount. So when I'm solving for it, if 48 is equal to AG, then AF is going to equal that 48 GF is going to equal that 48 divided by 2, which is 24. So now I know GF is 24. And then for the whole length, I just add them together. 48 plus 24, that gives me 12, 72. So AF is 72. So this property comes in pretty handy. I can also solve it a different way. If I know 48 represents 2/3 of the length AF, then similarly, all I have to do is multiply by the opposite, or the reciprocal, which is 3/2. That cancels out my fractions, and I get the length of AF. Half of 48 is 24, and 24 times 3 is 72. So here again, I get 72, solving it a different way. And I apologize if you hear my dog barking in the background. Okay, so we are headed back to our graphic organizer and back to the Orthocenter. And the Orthocenter is created by altitudes. So we're going to fill this in with altitudes. Okay, so an altitude is created by a vertex connected to the opposite side so that it is perpendicular to that side. So what we have here is, again, M. I'm going to highlight M. M is our orthocenter, and it is created by these altitudes. Now, an altitude connects a vertex perpendicular to the side. It does not make it a bisector. It is just strictly an altitude. You may also have seen this in triangles before. This was called the height of a triangle when we were finding areas in previous grade levels. So if I go from B down to Z with that right angle, that was considered the height of the triangle, which you use for area. Okay, here we call it an altitude. So altitude and height are the same thing. Okay, now let's look at an example. Okay, so with the orthocenter, this does not have any other properties at all. So what we have here is just the orthocenter. We just need to create the altitude of all three sides of the triangle. So we're going to find the orthocenter of the triangle. Now, being that I have to have a perpendicular line, many of you realized if you did the CK through 12 on the perpendicular bisector, we had to go back and use our perpendicular lines. Same thing here. So what we're going to do is I'm going to start at point A, and I'm going to draw the perpendicular bisector. Okay, so I need to look at the side across, and I need the slope. So the slope of BC I see as a vertical line. You remember slope, dude? That means the slope was undefined. And the perpendicular line to a undefined line, so my line perpendicular to it, that's going to be 0. So my 0 line is going to go, 0 slope is going to be that horizontal line all the way across here. Should be on the line. Trying my best to stay on there. Okay, so if I go to point B now, point B, I have to go to the opposite side, which is side AC. And so I need the slope of AC. So I'm going to go up 1, 2, 3 and over 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So that slope is going to be 3 over 7, which means my perpendicular slope is going to flip it and take the opposite sign. So it's going to be negative 7 over 3. So from point B, I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7, and to the right 3. 1, 2, 3. Okay, and there's that point here. And that line goes that direction. And you'll see it falls outside of the triangle. What that tells me is that this triangle is obtuse. Okay, so if your orthocenter falls on the outside, that tells me that my triangle is obtuse. Okay, then we've got point C, and it's going to go across line, or be perpendicular to line AB. And I'm going to find the slope. So I'm going up 1, 2, 3, 4, 5, 6, 7. And I'm going over 1, 2, 3, 4, 5, 6, 7. So that means my slope is 1, because 7 over 7 equals 1. So that means the slope of the line perpendicular is going to be the opposite sign and switched. Well, 7 over 7 would still be 1. So my slope is negative 1. So from point C, I'm going to go down 1 to the right 1, and down 1 to the right 1, down 1 to the right 1. Ooh, all three of my pretty lines intersect. And that's where it would touch the side. So now I have my orthocenter, which is where all three of my lines intersect. And it appears to be at this point right here. So my orthocenter is going to be at point 9, negative 1. 9, negative 1. And that completes our example for orthocenter.